Okay, practice test 2. Number 1, we have to find the circumference after given the diameter and the radius. So circumference is equal to 2 pi r, and also because 2 times r is the diameter, we can also say that it's the diameter times pi. So the first one is an 8-inch diameter. So we would say 8 times 3.14. And let's get the calculator out. 8 times 3.14 is 25.12. So 25.12. So that's the one, that's A for the diameter of 8 inches. Now when we're given the radius is 7 inches, then we would say 2 times 3.14 times 7. So that is 6.28 times 7, 43.96. And of course the units on each of those is inches. Now we're looking for the arc length when given the angle for number 2. So in this one we're still going to use these, specifically that equation right there, and we only want to find part of it, remember. So we're not looking for the entire circumference, we're only looking for 130 over, so the arc length is equal to 130 over 360. Now remember, this is the ratio, and then we're going to multiply it by that equation right there. And our radius in this case is 12. So 2 times 3.14 times 12. Okay, so get my fraction bar out. 130 over 360 times 2 times 3.14 times 12 equals 27.2. So 27.2. So that'll get us our arc length. Now, number 3 has us converting from either degrees to radians or radians to degrees. And in this case, it is degrees to radians. So remember that our ratio that we use is pi over 180 is equal to the radians over the degrees. Oops. So in this case, we have the radians and we're looking for the degrees. So we say pi over 180 is equal to 6.2 over degrees. So we cross multiply. Degrees times pi is equal to 180 times 6.2. Divide by pi, and we have in the numerator 180 times 6.2, and in the denominator 3.14. So this is 355.4 degrees. Now, most of the time when you're given an angle in radians, there's a pi involved. In this case, I left out the pi. I just made it 6.2. But most of the time you're going to see a pi. Now, if you're going from radians to degrees, like let's say that I've got, I set up my ratio here. Let's say I've got a measure in radians, and let's say that it is 3/5 pi, and I'm trying to find the degrees of this, so I'll go degrees. So what we do is we cross multiply, and we've got 3/5 pi times 180 is equal to pi times d. So you'll see that there's a pi on both sides. So I can just cancel them out like that. And the answer is going to be 3/5 times 180. So 3/5 times 180. So that is 108 degrees. So 108 degrees. Now if I wanted to find the radians after given the degrees, let's say that I've got, let's set up the ratio again, pi over 180 is equal to, let's say 120 degrees. Watch that be the amount on the test. I don't remember what the test question was. Anyway, so we cross multiply here, and we have 120 times pi is equal to 180 times the radian measurement. So this is what we're solving for, so I'm going to divide by 180, and in this case I'm only going to do the division with the numbers in it. I'm going to leave the pi there. Instead of converting it to 3.14, I'm just going to leave it as pi. So my radian measurement will look like, let's see, 120 divided by 180, and that is equal to 2/3. So the radian measurement will be 2/3 pi. So that is the radian measurement. I left the pi in, which is very common to do. It doesn't always have to be done, but it's very common to do it that way. All right, so let's take a look at number 4. Now with number 4, the angle that we're looking for is inside of the circle. So the equation for that is AB plus CD divided by 2. And AB is 52, so we've got 52 plus CD is 64. Then we're going to divide that by 2 like that. So let's see here. 52 plus 64 is equal to 116 divided by 2 is 58. So that is equal to angle 1. Now I'm not going to try to make all of these onto one video, so that is 1 through 4, and we're going to continue on after this.